questions? Yes, any questions? What to do? Huh? Any button? It is residence time so long. I internal itself. Just a yes, any questions? So everybody understood that how to calculate the traffic efficiency and any doubts on photosynthesis efficiency and traffic efficiency? Any doubts? No? Yeah, so basically we learned about efficiency. So mostly you can say the trophic efficiency and the photosynthesis efficiency. Whenever we are talking about the photosynthesis efficiency, so numerator is the GPP, that is the gross primary productivity divided by the total energy available. And for the trophic efficiency, so whenever we are calculating the trophic efficiency, numerator should be net primary productivity, okay, divided by the total energy available for it. Okay, so don't be confused with this efficiency. And also I told you to calculate the actual photosynthesis efficiency. Who has tried it? Yeah. Who has done it? But you have to take instead of 60, so 60 is required also to find out the Gibbs free energy, that is the net output energy. Okay, so you have to take that reaction photon with glucose, then what should be the output. So accordingly we have to find out the Gibbs free energy. Okay, so that would be the net output energy. So that divided by the HC by lambda. So So who has not done it, please do it. Okay. So now we will learn about population dynamics. So population dynamics means, first of all, we know that nobody is living solitarily, right? So nobody is just living isolated. So they all are organisms. So they are living in it, right? So we can call it population. Then what are the challenges to basically study the population? Population study. Okay. So there are several challenges. So first is hybridize with other species. Suppose mule. So we don't know what should be in which species we have to count. In the species or in the parent species. Right? So this is your problem. So for the hybridize. Then second, one genetic individual. So I think someone, maybe other people are saying that. So in your place there are 7 people such as one. Yes. Huh? So maybe you have counted that. Again and again you are counting that. Huh? So that may be different. So basically look at it. Then what geographical area to study? Suppose you are studying or counting the number of tigers in your forest. Obviously in a deep forest and a very lean forest. Right? So it is obviously study will be different. And also it will take time, it will depend on the time. And also suppose you are counting a fish in a pond and you are counting a tiger. Obviously time required will be different. And it will depend upon the types of ecosystems. Okay, so these are the difficulties to count the, or basically we can study the population dynamics. Okay. So next is the meta population. So you know about metastable state of an atom? Huh? Yes or no? Metastable state of an atom. What is that?
State between lower and higher state. Kind of state between lower state and excited
So the state where atoms will live with highest lifetime.
Yeah, so in between, right? From ground and excited state. So for us, though it's a smaller time, but for highest time it can stay. That means excited state. Right? So we are saying it's a metastable state. So similarly, in population dynamics, we can define the meta population. Right? So suppose in your city, or simply you can say India. So many people are going out and many people are coming in. Right? Suppose we can say a fraction of people going out from India. They may be living in several countries. So we can say suppose 1% or 2% of people going out. So that community means you can say occasionally they are interacting with the main population. Right? And even if when I am saying some people are coming in from other countries, right? So they are also not staying for a longer time, so they may go to their home country sometime, right? So this is also a community. So whenever we are saying that, so those are coming in immigrants and going out immigrants, right? So occasionally these immigrants and immigrants are interacting with the main population. So that population we can call it meta population. Understood? What is meta population?
The interaction of local population of a place with the immigrants and emigrants that are coming to that place and those who are living that place.
So basically you can say a fraction of people they are going out or coming in. So this fraction of people, so you can say they are interacting with So whenever we are saying, yes, क्या हुआ? So whenever saying population study, so population study means obviously with time and spaces. So we can call it demography, right? So basically population study means we can call it demography, right? So this is the, we can say, simple equation. Birth and immigrants, that means coming in. So that is the source of generation, and that should be approximately death plus immigrants. This is the basic equilibrium equation for the population dynamics. And obviously dispersion means, yes, and obviously we can say dispersion means simply immigrants and immigrants. So they are moving from one place to another place, they are mingling with the main population. Okay? And of course for the seeds, you can say that seeds, so through birds or some other, due to some other reasons also, so these seeds can be migrated from one place to the another place. So they are maybe, if they are getting the favorable conditions there, they can grow there. Okay? So this is the basic equilibrium of the population dynamics. Then dormancy. Do you know what is dormancy? Inactive states. Suppose one seed. So do you think in summer seeds will germinate? Mostly not. Okay? But still they are in the beneath of the soil. Right? So whenever they will get their favorable conditions, then they can germinate. So basically you can say rainy season or other seasons. Okay? But during their inactivation state, they are not dead. So simply they are in the dormant position. Right? So dormancy means, so they are inactive for a period. So whenever they are getting their favorable conditions, so they will grow.
Like viruses.
You can say. Okay, any cases. Okay, so basically for a period, inactivation is there. Whenever they are getting their favorable conditions, they will grow. So this is the dormancy. So dormancy means that is the inactivation period. Okay. So as I said, the study of population dynamics is called as the demography. So what we can study, so basically the population size, about the number, then the ages of the organism for the different kind of age groups, then the age at depth, cohort, and long-term population study. So what is cohort? Yes, group of people who has similar characteristics. Okay, or same characteristics. You can say same, but you can say similar characteristics. Right? So a group of species, so who have similar characteristics, then we can say cohort. So in this population dynamics, we can study these kind of things. So basically, population number is mostly important with the age group. Okay. So suppose I will say that you count the number of ducks inside the IIT campus. Can you count?
Number of
Ducks. Huh?
after some extent
So you can count. How much time you will take?
1 to 2 days.
1 to 2 days. Sure. Huh? So suppose fence is not a shield. Maybe some can go out. Maybe some can come in. Then how can you count? Then you definitely you have some error.
GPS tags लगा लेंगे.
GPS tag.
This is called not.
So suppose बाहर चला गया था, if it's go out, that is not in your population now.
Change होता रहेगा.
So 2-3 बार काउंट करते हो देखिए.
Then you will take average. But it will take much more time, na?
Yes.
Huh?
Yes sir. Pure accuracy.
So basically, so even if we don't count exactly, but we can estimate up to some extent. Maybe it is overestimation or maybe it will be underestimation. Right? So there is a Lincoln index method to estimate the population size. Okay? So this is an estimation. Basically, estimation. First, catch and mark. Suppose you catch 15 ducks. How will you catch? It is up to you. So you maybe put a catch. Inside the catch you can put some meat. Right? So it is depends upon you how you will catch. Right? So and mark them. Just put GPS tag, whatever, any kind of a tag. Right? So you can put M. So you can put M. Suppose you got 10 ducks. Okay? Now you mark them. So next time whenever you will see or you will caught a catch, so you may identify. Earlier I had caught it. Right? So first is catch and mark, so that you can identify further in the next step. Next phase is release for a period. अभी mark कर दिया. After marking, you just release them. ठीक है? For a sufficient period of time, so that they can mix with other ducks to whom you could not catch. Right? Maybe they will share their experience with them. So now second type, recapture. So in this recapture, if you are giving a trap, similar kind of trap earlier, so may not these capture ducks, may not will come. Okay? But so it will depend upon you how what should be the second time capture. So in that recapture, suppose those are all ducks are not smart, right? Even if some are hungry, they can also fall in your trap second time also. So that is, you can say C, right? Inside in C, so both marked and unmarked are there, right? So both marked and unmarked there. So what should we take? Suppose we can keep it 6. Okay. Now take the ratio basically. From C animals, some will be marked. So you can say some will be marked is R. So you can, and what should be R? Suppose out of 6, so it may be, okay, suppose 2. Okay, then take the ratio. So we want to estimate the final population, right? So that is n. So final population is, you can take n. Okay, and the first time you have taken n, the capture, catch and the mark. So that should be n. So you can take ratio n by n. Then what should be the right hand side, which should be approximately equal to this? Why? It's already written there. So what? Obviously, this is the R by C. This is the same ratio according to the n by n. R is the recapture one and C is the total one. Right? Similarly, for the first case, n is the total one, m is the capture one. Right? So this way we can equate to that. Then what should be n?
Otherwise, it ends.
What is the number? What is the number? Ranjan, what is the number? N.
And it's just a model.
Huh?
Model.
30. So you can estimate the total number of ducks inside the campus is around 30. But in this number, always, so there is a fraction who can go out and a fraction can come in. But overall estimation will be this much. Right? And as I said, this is an estimation only, not the exact value. Right? Not the exact value. So what is the, you can say, some problems or errors in this formula, in this method?
Sir, of course, because it will give an estimate, it is a ratio. It is not sure that the exact number will be, the total number of ducks will be there, because maybe sometimes with another experiment that we perform, we have some total captured maybe different.
So on which parameter in this here, mostly this formula depends.
The how many, sir, R and C, that how many of them are already found.
Most important parameter, only one parameter.
Recapture
Ratio, equality of the ratio.
Recapture. So basically you can say, if you will see n equal to nc by r, so basically r. Right? So that is the most important parameter. Suppose you could not catch a single marked one. Obviously it will be higher side. Right? Then it will give you an overestimation. Right? So suppose n equal to mc upon r. So if r is very high, then you will get an overestimated value, very large number. Right? If r is very low, sorry, if r is very high, then you can underestimate. If r is very low, then overestimation. Right? This is the problem of this estimation. Obviously, estimation means estimation. We have to just find out a number, just indicative number. Right? And this R means recapture thing. It will depend upon what the plan you are doing. Right? So some may be said, suppose I am asking you, for the both the time, the task should be same or it should be different?
Should be different.
Should be different. Why? One second.
Sir, because if we put the same trap, the prey will get some knowledge about the previous experience and they may not fall for it.
But all are not smart.
Sir, but at the same time,
Even if
don't
many-
capture anyone becomes zero.
so now you are very smart, but sometimes you are just scanning like a digital. Digital, na? Huh? Anybody else count digitally? Eh? No, good. If you know something, you are aware about these things, but still you are. Okay, so if it's the same trap for the both the times, maybe even if someone is hungry or something like that, they can. But if it is a different trap, that is a good idea for the mixing of the other things, right? So for the both the times, the trap should be different, and it should be in a physical way. So you should do that. And the second thing is the releasing period. So that should be sufficiently high so that they should forget. If you are putting the same trap, then your releasing period should be so long, so they should be forget. Okay? So this is the estimation method. So for any kind of organisms, so you can use this. You can use this Lincoln index method. Everybody understood? Okay. So then, population, because we have so huge number of data, right? How can we represent this population data? So there are three methods. So one is live table, another is population pyramids, another is the survivorship. So what is live table? So whenever we are presenting the data in terms of live table, then simply we can represent them in terms of rectangles or squares, and another is the triangle. So basically the triangle represents what is the probability, because suppose in 2024 we are saying population is this much. In 2013 what it would be? We don't know. We have to only say probability according to the previous statistics. Previous year's population data, we have to make a statistic. Then we can say, yeah, maybe this would be the population at 2030. Right? This is the probability. So this probabilistic data will be represented in triangle. So basically, what should be the population or what should be the number for the next stage? So next stage means it may be time or it may be space also. Can you give some example for space? Because time I told you. Yeah, but
Migration.
yes, migration. So these things, basically the things, suppose it is frequently happening, regularly happening. Okay, the first time we can say. So suppose migration, suppose from winter from Siberia to India, so they are coming several birds. So we are saying that every year they are born. Okay, so you maybe after 5 years, what should be the number? So that can, and also in that same place also. Okay, and suppose we know that from the now we are at 2013, and we know that at this stage what is the exact value. So that this data, so already the known data, okay, will be represented through squares or rectangles. Okay, at this stage, present stage. So this is a simple way for representation of the data, population data. Any questions? So next is population pyramid. So you can see which is the age groups this pyramid has made, and for both male and female. And this is the Russian data at 1959. right? So this is also a simple, relatively very simple way of presentation, right? You can see for the both male and females, this pyramid is not symmetric, right? Is it symmetric? Can you give your inference? Possible to this. Why it's not symmetric? It's quite symmetric but not exactly. That's what I'm saying, yeah. Can you say can you give some reasons why it's not symmetric?
So because the particular as for the particular males, per number of males, there are not equal number of females.
Why?
That is the data of which year?
1959.
So at that time, what like the condition for survival were not that much like good for their. So the women actually used to stay at home, but men were there to go out and find the all that they were doing the necessary items.
It is very rare and well.
Let him finish.
Okay. So sir, basically that can be the reason, right? Men were the
But it is the data is showing that the men are more in number. Women are in less in number.
So female fitting side, this is maybe the reason. Female fitting side may be the reason. So the fitting side, female fitting side may be the reason that
Any other reasons? Loudly.
in that age group the ratios of females
Some possible reasons. Okay, so maybe one war, so maybe due to that, humans and else maybe we don't know. So what is happening, right? But even if in any time, in any country, most probably this will not be the symmetry. Okay, so basically we are saying this is a basically representation of data with the age groups. So this is a better way for the presentation of it compared to the light table. But light table and pyramid, they are different for the different kind of data, right? But if you say that age groups, then this is a better representation of the human or any kind of. Okay. So next is survivorship curve. So what is survivorship curve? So here in the x-axis is the time, okay, and y-axis is the population size, population number, right? Time versus number. So the first graph, so this is for a mountain goat. So lifetime is around 14-15 years. So the upside is here around up to 30 years. Right. So this is the absolute graph. The first graph is the absolute graph. I think all of you know about why log of the graphs are taken.
because they cover the large scale. They cover the large scale.
Large scale.
Large, you can say large numbers, large range of numbers.
We can no problem for the absolute axis. We can use the large numbers also. Why we are taking the log of the graph?
So because exponentially population increase होती है. Log लेने से simple हो जाता है represent.
Simpler means
Graphical representation of values is what we take formulas.
scale down. How?
In a small scale, we can represent large data and we can compare it.
So basically variation. right? So variation you can say in the absolute value you can give a very large variation, that means fluctuations. To minimize the fluctuations or large variations, we can take the logarithm. So here you can see up to 9 years the curve is very flat. What does it mean? Then suddenly curve is funny. It is exponential after 9 years. How can you explain this graph?
Survival rate at lower rate of damage, lower, as they may fall prey to predators. As they may fall prey to the predators. So population decreases eventually, and then the certain age they can become normalized.
So you are saying at the old age, so they will cut more by the predators. Early age. But I am saying early age number is much more.
Then the sheep can survive 20 years. Lifespan.
Yeah, that is the. What did I say? Suppose 15 years. The lifetime. That is the old age death. Right? But you can see from the obviously from 9 years, old age can be started.
Also diseases, which becomes 9-year-old and diseases because they use.
So basically, simple thing is mortality rate for the younger age is you can say very less, and older age is very high. Right? So that means we are saying that at the younger age, so everything, whatever you need, so that is means you can say available for that. Right? Suppose for human beings. So if for the younger age, hospitals, food, anything is available, then mortality rate will be drastically changed. If in those cases, so if you are not getting the food or hospitality facilities or some other things, obviously mortality rate will be increased. Right? So just here we are saying at the younger age, so they are getting their all facilities. Right? So that's why mortality rate is less. But whenever they are coming to their older age, so they could not continue basically the survival rate. Right? So they could not take the advantages of the previous time. So that mortality rate suddenly increases. Mortality rate increases at the older age. And in some cases, suppose these are the 3 cases. These 3 survival systems. The first one, so basically mortality rate is directly proportional to the time. And second one is the already this graph. And third one is, how can you explain this third graph? It is opposite, na?
High mortality at young.
Amber, can you explain
So I have a question.
the third graph?
No, I have a question on that one. What you were explaining, what you just explained.
So I told for the first graph means in the third graph the first curve, right? The middle one. So that is in that case mortality rate is directly proportional with time. Okay? So whatever, even if their facilities are not, but with time their mortality rate is just.
So who provides the facility?
We don't know. We can say the who will provide. For human beings, obviously we are providing. Human beings they will provide, na. Suppose for the other organisms, so they can't get, na. So basically they will, whatever they will get from the nature only.
So my question is on. So for example, let's say impala, like in the forest. So these ones they usually move with the kids. So when the predator comes, they order like impala.
This is the process it can't be changed. So this is the process that is included here.
So this cave is true for all
All
organisms.
organisms. So simply in the second, third curve is saying that at the early stage, so maybe they are not, the younger ones, they are not getting such facilities, right?
Yes.
So that's why
All the
mortality
three.
rate is very high.
All the three possibilities are there.
So whenever at their older age, so basically they are taking advantages from the previous time. Okay? So already they learned from their mistakes, past mistakes. Now they are recognizing, yeah, we should take advantage.
They have been pre-planned their.
So that's why at the older age, so their mortality rate decreases. Okay? So this is the only thing. Everybody understood? Any questions? Yes or no? So basically, these three ways, in these three ways, we can represent the population dynamics. The first is the life tables. So in the life tables, basically we can present the triangles and the squares. Square or rectangles represents the exact data at that stage only, or at stage may be time or space, and the triangle can be represent the probability for the next stage. And then population pyramid, so that represents the with the age groups from the both male and female.
The comparative study of
Yeah. And the third one is the survivorship curve. Survivorship with time, basically it is defined with their life table. Life table basically you can say the lifespan. Okay, according to their lifespan, so what is the number and what is the survival rate? Okay. So then the population regulation. How can, suppose if there is no regulation to control the population? So what should be the population? It will increase exponentially. So that is happening now. So suppose in this case, suppose this is the t equal to 0. So very few was there numbers, right? So they are rate, increment rate. Okay, so just mind it, rate, increment rate. So increment rate, because number of population is very low, so that's why increment rate also would be less. But whenever they are getting this at a certain threshold number, then suddenly their rate is increased. So that is a exponential, right? So this looks like a J-shaped curve, right? So can you tell me, like what point we are here for the human
we
population?
have already crossed the line.
Huh? Yeah, definitely we have crossed now. Huh?
It is rising exponentially.
It's difficult, huh? So if there is no control, obviously this J-shape will be just arranged. But do you think, is it possible? Always it will be increased without regulation.
At some certain point in time, sir, there will be lack of resources, there will be lack of sir, all the essential things to survive.
Yes.
So at some point it will be steadier and there is mortality.
How?
Due to the death and the other major issues.
But death you can say, for Japanese people, the death rate is very low.
But the advent of medical facilities are also reduced the mortality rate.
The facilities as well as the food.
Yes.
If number is more, then obviously there is a food scarcity, right? So there are many things. So that imposed from the environment only. Okay? So that's why this J-shaped curve would not be there. So how it would be? After regulation means basically whenever the environmental regulation imposed, then definitely it would be like this. Okay, so this is just looks like a S cell. Okay. Okay, so please read about this. Next class we can continue this.
And if it will not be regulated, sir, there may be a sudden fall also.
Yes.
Because
So even if after that, this can be like that.
yes, sir. Natural calamity sometimes.
Yeah, it's not.
Yes,
So whatever
I take.
So I hope everybody has submitted the assignments. Huh? Everybody has solved those numericals? Huh? Who found it difficulty? Every questions everybody has solved?
Yes, sir. Because it's an exception.
Huh? Ankit?
Last question of numerical sheet 1.
Huh? Both the sheets you have solved?
Second sheet I got solved. Second sheet I got solved.
You solved it. I think the deadline was over. Deadline over, na?
Yesterday was the
Yeah, yesterday was the deadline. Avirasi, Kirti, Archie, Saloni, Naina, Bharti, Vinayak, Vikas, Ritu, Sajiraman, Moshkumar, Mukta, last class not there. Harshit Rai, Prasan, Abhay Beg, Ankit Thasa, Anushka, Ayush Singh, Pranjal, Ripsik, Aditya, Vishal, Divyanshu, Divyanshu na? Narendra, Punit, Sarvesh, Rohit, Tushar, Sanidhya, Raghunath, Shashwat, Saurabh, Banwarlal, Shivam, Shivam Vijay, Arshit Kumar, Deepika, Khushbu, Aniket, Yashasvi, Dipanjan, Anushka Patel, Subhajit, Prabhakar, Rajit, Shivan, Shailesh, Naval, Mohit Mehta, Divan, Aryan,
Yes, sir.
Jaya, Hamlet, I want to take the reaction.